In this example, we're going to talk about implicit differentiation and do another example of that. So the example is use implicit differentiation to find dy dx. Here, the equation that they give us is sine of pi xy squared equals y to the fourth times x minus 1. And in this example, they're wanting us to find the derivative, right, dy dx, at a specific point. That's when x equals 1 and y equals 1. Okay. So what we're going to do is to take the derivative first, right? Don't plug in the x and y first, right? Take the derivative first, right? And once you take the derivative, then plug in 1 for x, 1 for y, and then solve for the derivative. Okay. All right. So first off, we're going to take the derivative of the left-hand side over here. In the derivative of the left-hand side, we can see that we have sine of some complicated stuff inside here. That makes taking the derivative of the left-hand side a chain rule. Okay, so the inside part will be this pi xy squared. The outside part will be sine. So once you know the inside part and outside part, then you just run through the 3 steps of the chain rule. Step number 1, take the derivative of the outside part. The outside part is cosine. Okay, the outside part is sine. The derivative of sine is cosine. So that would be the first step there. Then second part of the chain rule is just leave the inside part alone, right? So just rewrite the pi xy squared inside the derivative of the outside function. So again, we didn't really take the derivative of pi xy squared. We just rewrote it inside there. Okay, and then the third step of the chain rule is to multiply by the derivative of the inside function. So the inside function is a constant, just a number, right? Pi times x times y squared. Okay, so the first thing, right, to understand is that pi is a constant, so I can use the constant multiple rule here. So the constant multiple rule says if I have a constant, a number, right, times a function, right, then I just to take the derivative of that, I just rewrite the constant, which I just did right here, and then I just multiply by the derivative of the function part, in this case xy squared. Okay. All right. So looking at xy squared, I need to take the derivative of that implicitly. That's going to be a product rule. Okay. I have x times y squared. Remember, y is taking the place of some more complicated function of x. Okay, so I have 2 functions being multiplied by each other, and that is the product rule. So to do the product rule, first I would take the derivative of x, which is just 1. Okay, and then I'm going to leave the other part alone, the y squared. I'm just going to rewrite that. So no dy dx there because I didn't take the derivative of y squared. I just rewrote it in there. All right, next the product rule says put a plus, right? Okay, and then now I'm going to leave the x alone because I took the derivative of it the first half of the product rule. Okay, and then the y squared, which I left alone the first go round, now I'm going to take its derivative. So the derivative of y squared is going to be 2y, right? And because I took the derivative of something involving the y there, I'll need the dy dx to complete the chain rule, right? Remember, there's some y is taking the place of some complicated formula, and that will essentially be the inside part. And so I need to the third step of the chain rule is to multiply by the derivative of the inside part. So whatever is in there, take y is taking the place of, take its derivative. We just don't know what it is at this point, right? Okay, and so that is the derivative of the left-hand side. I'm going to put the equal sign in there. And now I'm going to work on taking the derivative of the right-hand side. So over on the right-hand side, I once again have a product of functions. I have y to the 4th power times x minus 1. Okay, so I'm going to have to use the product rule. I'm going to take the derivative of y to the 4th first. The derivative of that using the power rule would be 4y cubed, right? And I took the derivative of something involving y, so I'm going to have to complete the third step of the chain rule and multiply by dy dx. So So that would be the derivative of y to the fourth. And the product rule says leave the x minus 1 alone. Just rewrite it. Next, the product rule says put a plus and then reverse that. So the y to the fourth, this time you leave it alone. Don't do anything with it. And then I'm going to multiply by the derivative of x minus 1. The derivative of x minus 1 is just 1. Okay. So that's it as far as taking the derivative. I've taken the derivative, and now I'm just going to clean it up slightly. Here, the only things I really did were that I pulled the pi out in front of the cosine and simplified that 1 times y squared. I wrote this as just 2xy. Here I just pulled the x minus 1 out in front of the dy dx, and just y to the fourth times 1 would be y. Okay, so I just cleaned it up slightly in there. And now in this problem, unlike in example 1, they just wanted the formula for dy dx. Here we want the derivative dy dx at a specific value for x and y. So you could solve for dy dx algebraically and get the formula and then plug in the numbers that they give you. But you can also just plug them in now and then just solve for dy dx using the numbers in this case. So that's what I'm going to do. So it looks kind of bad at first, but what I do is just everywhere where I see an x, I plug in a 1. Everywhere I see a y, I also plug in the 1 because that's the two numbers that they gave me. So I plug those in the appropriate spots. And then I just start simplifying that out. Okay, so I'm going to have this pi out in front. If I simplify here, I just have cosine pi on the inside of this. 1 squared is 1. 2 times 1 times 1 is 2. Over here, I have 4 times 1 cubed, but then I multiply by 1 minus 1. 1 minus 1 is 0. So that's going to zero this entire part of the expression out. And I'm just going to get a 0 here. So that's why I have this 0. And then 1 to the fourth is just 1. Okay, so that's what I have when I simplified it out. The cosine of pi, right, that's just equal to negative 1. So that's why I have the negative 1 there. And then 0 plus 1 is 1. Okay. And simplify it a little further there. Minus 1 times pi would be minus pi. And so now what I want to do is to, now that I've got it fairly simple, is to solve for dy dx. So one of the things, you can either divide minus pi from both sides, but I guess I'm just going to distribute it through the parentheses here. So minus pi times 1 is minus pi times 2 dy dx is minus 2 pi dy dx equals 1. And so now I just want to solve for dy dx. So I would add pi to both sides and get minus 2 pi dy dx equals 1 plus pi. And then last step is to divide both sides by minus 2 pi, and I will get that value here. Okay. So dy dx, the slope of the tangent line, and the derivative right at the point 1, 1 for this equation is 1 plus pi divided by minus 2 pi. And if you wanted to, you could plug that into your calculator and get an approximation for what that will be. So, but pi is about 3.14, so that's about 4.14, and this is minus 6.28 roughly. So, but anyway, you could, if you wanted the decimal approximation, you could plug that in your calculator and get it.